Welcome to one more session of this video lecture in which we are going to study about the Ohm's law in electricity. Most practical approach of the Ohm's law. Now what Ohm's law is, before that again we will go little bit back and then come to Ohm's law. What we know is that the substances which are able to conduct electricity are called as conductors. Conductor supposed to have large number of free electrons. The free electrons are in a state of random motion. When this conductor is connected to a source of electrical energy, that is a battery, then electric field is produced at every cross section of this conductor. Battery positive is connected to end A of the conductor and battery negative is connected to end B of the conductor. Therefore, the end A of the conductor is at higher potential and B is at lower potential, and the electric field produced at every part of the conductor is from higher potential to lower potential. As electron is negative charge, the force act on an electron in an electric field in the direction opposite to that of electric field. Therefore, all the electrons moves towards a higher positive potential, and the electron moves with a velocity that is called as the drift velocity of the electrons. Now, the electronic current is from negative of a battery to positive of a battery, and conventional current is supposed to due to the positive charges and it is in the direction of positive charges. Therefore, the electronic current is from B to A and the conventional current is from A to B. The difference of potential between A and B, let it is represented by V. The difference of potential between A and B, I call this as the potential difference between A and B is represented by V. V is the potential difference between the ends of the conductor and I is the current flowing through the conductor. Now, instead of this, if for the same conductor, let the conductor is same and this same conductor is connected with a battery with large EMF, and the current in the conductor is measured with the help of ammeter. Then the potential difference across the ends of the conductor, let it will be V2, and the current that flows through the conductor is I2. Here, for the sake of convenience, in the first case we will consider V1 is the potential difference and I1 is the current flowing through the conductor. मित्रांनो, आपण इथे काय केलंय ते थोडक्यात पाहू. एक कंडक्टर घेतलाय. Metals are the good conductors of electricity. या कंडक्टरला सोर्स ऑफ पोटेन्शियल डिफरन्स म्हणजे एक बॅटरी घेतलेली आहे. आता उदाहरण म्हणून आपण असं समजूया की आपल्याला बाजारात एव्हरेडीचे जे सेल्स मिळतात ते 1.5 व्होल्टचे आहेत. ते 2 सेल एकत्र घेतलंय म्हणजे इथे आपल्याला 3 व्होल्ट इतकी बॅटरी आहे. 3 व्होल्ट ची बॅटरी आहे आणि इथे पोटेन्शियल डिफरन्स ए आणि बी च्या मध्ये जो निर्माण झालाय तो V1 आहे आणि या बॅटरीमुळे वाहणारा करंट I1 आहे. ते मेजर करण्यासाठी आपल्याकडे आहे, सोय आहे. कशाच्या साह्याने मेजर करणार आपण? सिरीज मध्ये एक अॅमीटर लावूया. हे अॅमीटरचं पॉझिटिव्ह, हे अॅमीटरचं निगेटिव्ह. हे का वाहतं? तर त्याच्यात फ्री इलेक्ट्रॉन्स आहेत. त्यांना मग इलेक्ट्रिक फील्ड मध्ये ती आली की मग त्याच्यावर फोर्स ऍक्ट होतो आणि मग ती इलेक्ट्रॉन निगेटिव्ह कडून पॉझिटिव्ह कडे, लोअर पोटेन्शियल कडून हायर पोटेन्शियल कडे जायला लागतात. इलेक्ट्रॉनिक करंट B to A असेल तर कन्व्हेन्शनल करंट A to B असेल आणि हा कन्व्हेन्शनल करंट मोजायला हे अॅमीटर आहे. दुसऱ्या फिगर मध्ये तोच कंडक्टर आहे. त्याच कंडक्टरला इथे आपण जे सोर्स ऑफ इलेक्ट्रिकल एनर्जी जी बॅटरी लावणार आहे त्याचं EMF जास्त आहे. त्यांनी दिलेलं पोटेन्शियल डिफरन्स आधीच्या पेक्षा जास्त आहे. इथे आपण 2 सेलचा विचार केला होता 1.5 व्होल्टचे, इथे 4 सेलचा विचार करूया. 4 सेल लावल्यावर ए आणि बी च्या मध्ये असलेलं पोटेन्शियल डिफरन्स V2 हे V1 च्या दुप्पट आहे. तर इथे आपण असं करणार आहोत, जेव्हा पोटेन्शियल डिफरन्स V1 होतं तेव्हा करंट I1 होता, जेव्हा पोटेन्शियल डिफरन्स V2 होतं तेव्हा करंट I2 होता. आणि मी आता सांगितलं हा V2 हा V1 च्या दुप्पट आहे. In the first case, we applied a battery whose EMF is 3 volt. In the second case, we applied a battery whose EMF is 6 volt. It means that potential difference developed in the first case is V1 and potential difference developed in the second case is V2. This V2 is obviously double that of the V1. Then it has been observed that the current I2 is equal to twice of I1. With this simple experiment, what we are able to conclude here is that with increase in potential difference, there is increase in current. This is the Ohm's law. Ohm's law gives the relation between the potential difference across the ends of the conductor and the current flowing through the conductor. The simple practical approach of the Ohm's law states that as far as the physical state of the conductor remains same. What is the physical state of the conductor? As far as the material of which the conductor is made up of is the same. As far as the length of the conductor is the same. As far as the area of the cross section of the conductor is same. As far as the temperature at which the conductor is kept is the same. As far as the dimensions of the conductor, length and cross-sectional area, the material of the conductor and the temperature of the conductor are same, we used to see that the potential difference across the ends of the conductor and the current flowing through the conductor are related to each other, and this relation is Ohm's law, and Ohm's law states that the current flowing through the conductor is directly proportional to the potential difference across the ends of the conductor as well as far as the physical state of the conductor remains same. This is the relation between the current and the potential difference given by Ohm's law. According to Ohm's law, as far as the physical state of the conductor remains same, the current flowing through the conductor is directly proportional to potential difference across the ends of the conductor. Or I will write the potential difference is directly proportional to the current. The converse is true in this case, but it is not necessary every time. But in this case it is true, I directly proportional to V or V directly proportional to I. In order to remove this proportionality, I have to write some constant R into the current. Therefore, we will have a famous relation V is equal to R into I. This R is a constant for a given conductor. This R is a constant for a given conductor and it is called as the resistance of a conductor. This resistance of a conductor is equal to V divided by I. Now, you will see that this resistance of the conductor R is equal to, it is potential difference divided by the current, or I will write here the current is equal to V divided by R. More is the value of resistance, smaller will be the current flowing through the conductor. As far as the potential difference across the ends of the conductor remains same, this current is inversely proportional to the resistance. It proves that resistance is nothing but the opposition to the flow of current. Resistance is the property because of which the conductor is able to oppose the flow of current. More is the resistance of the conductor and less is the current. And the device which is used as a resistance is a resistor. Resistor is the device which has a resistance which opposes to flow the current. This resistance has a unit of resistance. Unit of resistance is Ohm. Symbolically, it is represented by capital Omega. Now, from this what we are able to write here is that 1 Ohm is equal to 1 volt divided by 1 ampere. Resistance of a given conductor is said to be 1 Ohm if 1 ampere of a current flows through a given resistor when a potential difference of 1 volt is applied across the ends of the conductor. A resistance of a conductor is 1 Ohm if 1 ampere of the current flows through the conductor with a potential difference of 1 volt across its end. The resistance and the conductance are reciprocal of each other. The conductance is a reciprocal of resistance. Therefore, unit of conductance is Ohm inverse. or Ohm inverse, or it is written as Simon. Resistance is a very important property of a conductor, and with this Ohm's law, and what do we mean by the resistance, we are able to see some of the very basic numericals. We will take one or two as an example. अरे आता काय करू माहिती का, आपण फार सोपी गोष्ट करूया. काय करूया, पहिलंच उदाहरण घेऊ. पहिल्या उदाहरणामध्ये मी काय सांगितलं होतं की दोन सेल लावले, तर पोटेन्शियल डिफरन्स, त्यातले इंटरनल रेजिस्टन्स, एनर्जी अगेन्स्ट द इंटरनल रेजिस्टन्स, ह्या गोष्टी पुढे शिकणार आहोत आपण. त्याला सध्या निग्लेक्ट करू. पोटेन्शियल डिफरन्स अक्रॉस द एंड्स ऑफ द कंडक्टर 3 ओहम आहे, सॉरी 3 ओहम नॉट, आणि 3 व्होल्ट आहे. कंडक्टर मधून अॅमीटरनी मोजलेला करंट हा 1.5 एम्पियर. तर कंडक्टरचा रेजिस्टर किती, तर कंडक्टरचा रेजिस्टर काढता येतो. कसा काढता येईल, आर बरोबर आहे व्ही डिवायडेड बाय आय, म्हणजे 3 डिवायडेड बाय 1.5. तर रेजिस्टर ऑफ अ गिवन कंडक्टर इज 2 ओहम. दिस इज द व्हेरी सिंपल थिंग दॅट वी कॅन डू. ओहम्स लॉ वरून ही फार सोपी गोष्ट करता येते. हे पहिलं एक्झाम्पल आहे, जे एकदम बेसिक न्यूमेरिकल सांगितलं मी तुम्हाला. दुसऱ्या वेळी आपण असा विचार करूया की आपण कंडक्टरच्या अक्रॉस लावलेला पोटेन्शियल डिफरन्स हा 6 व्होल्ट आहे असं समजा. कंडक्टरच्या अक्रॉस लावलेलं पोटेन्शियल डिफरन्स 6 व्होल्ट आहे, आणि जो कंडक्टर आहे त्याचा रेजिस्टन्स आहे असं समजू की ते 12 ओहम आहे. तर अॅमीटर न लावता त्या कंडक्टर मधून पास होणारा करंट आपल्याला कॅल्क्युलेट करता येईल. वी आर एबल टू कॅल्क्युलेट द करंट थ्रू द कंडक्टर, अँड इट इज I is equal to V divided by R. V is 6 and R is 12. It is equal to 0.5 ampere. These are the two basic numericals which are based on Ohm's law, with the help of which we are able to see what is the physical significance of Ohm's law. Thank you very much.